Hi there, here's Qingjun Meng, and thank you for your interest to our recently published paper using a dynamic earthquake simulator to explore tsunami earthquake generation. In this study, we use a fully dynamic earthquake simulator to explore how friction parameter on fault plane could influence tsunami earthquake generation. Our basic model, model 1, is shown here. In our model, we use the rate and state dependent frictional aging law, and it depends on some friction parameter A and B, critical distance, and normal stress. When A minus B is smaller than 0, it represents the velocity weakening, and A minus B is larger than 0, represents velocity strengthening. So in our fault plane, it's mostly velocity weakening, but it has two asperities shown by dark blue patches, has very small A minus B value, and earthquake can nucleate from asperities. Between asperities is the conditional stable zone, and earthquake can propagate into the conditional stable zone. A minus B is slightly larger in this zone. And over Z1 asperity, on the left corner, we have the high normal stress. It represents some high relief topography, like seamount. And on asperity Z2 on the right corner, that has a low normal stress, represents some low relief topography high. During our earthquake cycle simulation, we find there are two types of events. One type ruptures both Z1 and Z2 asperity, other type only ruptures Z2 asperity. So here is an example. For the first type, ruptures nucleus from Z1 asperity, and it has a larger energy because Z1 has a larger strength. It can rupture the whole fault plane. And another type of event, nucleus from Z2, it's propagating into the conditional stable zone, but stopped by Z1 asperity. So Z1 serves both as an asperity in one event and also as a barrier in another event. So we have model 2 compared with model 1 has a longer dimension, and the asperities are further separated. And then the source time function of this model is longer compared with the model 1. So that's how the fault dimension influence earthquake characteristics. We also modulate the friction parameter A minus B on the conditional stable zone, change it from minus 0.001 to minus 0.004. And for all the events, we calculate their normalized source duration to compare with each other. For the historical events, the normal historical tsunami earthquake, the normalized source duration ranges from 9 to 23 seconds. And for our simulation, we'll find that when A minus B stays in this narrow range, minus 0.02 to minus 0.03, we can observe this normalized duration in this range. When it's too small or too high, it cannot generate this kind of tsunami earthquake. And we have other types of models shown here. You can refer to them in our paper. So generally, this is a brief summary. We can simulate tsunami earthquakes when using the model with asperities embedded on the conditional stable zone. In this model, we use a uniform velocity structure. But in our recently published in our recently work, we'll publish soon, that we explore how the upper plate material properties can influence tsunami earthquake characteristics, and we can compare it with the friction properties. And thanks again for your attention.